Aerospace engineers are often surrounded by myths and misunderstandings. People hear the phrase and immediately think of rocket scientists at NASA scribbling equations that nobody else can understand. While that image has some truth to it, the real story is much broader, more practical, and a lot more fascinating. Aerospace engineering is the branch of engineering dedicated to the design, testing, and improvement of anything that flies within the atmosphere or travels beyond it into space. That includes airplanes, helicopters, satellites, drones, missiles, rockets, and even futuristic technologies like hypersonic vehicles or interplanetary spacecraft. If it lifts off the ground, an aerospace engineer probably had a role in making it possible. Within the field, there are two traditional categories: aeronautical engineering and astronautical engineering. Aeronautical engineers focus on flight inside Earth's atmosphere, things like passenger jets, cargo planes, and military aircraft. Astronautical engineers, on the other hand, concentrate on spaceflight, which means satellites, space stations, rockets, and vehicles designed to explore other planets. In reality, though, most aerospace programs and careers blur the line between the two. A single engineer may learn about both wing aerodynamics and orbital mechanics, because the principles of physics and problem-solving connect them all. At the core, aerospace engineers are problem solvers. Their work combines mathematics, physics, and creativity to handle challenges that push the limits of technology. Want to make a jet engine more fuel efficient? That means studying thermodynamics and fluid dynamics. Want to design a satellite that can survive the extreme cold of space? That calls for expertise in materials science and heat transfer. Want to control a drone so it hovers steadily in the wind? That's a problem in dynamics and control systems. Aerospace engineers use theory, but they also test their designs in simulations, wind tunnels, laboratories, and eventually, in full-scale prototypes. Another common misconception is that aerospace engineers only work for giant space agencies or aircraft manufacturers. While organizations like NASA, Boeing, Airbus, and SpaceX are big employers, aerospace engineers also contribute to industries that may not immediately come to mind. They can be found in defense, software development, robotics, automotive design, renewable energy, and even research labs working on climate science. The skills of analyzing motion, predicting forces, and building reliable systems apply to a wide range of problems. Teamwork is another defining feature of aerospace engineering. Designing a new airplane or spacecraft is too complex for any single person. Engineers specialize in different areas. Propulsion experts work on engines, aerodynamicists study airflow, structural engineers design the frame, and systems engineers make sure all the pieces communicate. Together, these teams create machines that not only fly but do so safely, efficiently, and reliably. So, who are aerospace engineers? They are the innovators who bridge imagination and reality. They are the people shaping the way humans travel, communicate, and explore. Whether it is making commercial flights smoother, reducing emissions with cleaner engines, or laying the groundwork for a mission to Mars, aerospace engineers stand at the forefront of human progress. Far from being just rocket scientists, they are the dreamers and problem solvers who keep humanity moving forward into the skies and beyond.